Uh, Hello, everyone. Good morning. Happy Friday. And welcome to our UCI ITS seminar. My name is Siwei Hu, a third-year PhD student at ITS. Today, we are so glad to have Mr. Randy Iwasaki to give us a presentation on cloud storage and data analytics and the impacts on transportation. Mr. Randy Iwasaki is the leader of the state and local transportation for Amazon Web Service. In that position, he leads AWS data support and analysis service for state and local transportation agencies, including artificial intelligence support, use of AWS service in developing new technology in transportation, data analysis methods for policies and planning analysis, traffic operational support, and other uses of AWS service by the state and local transportation agencies. Prior to joining to AWS, Randy served for over 10 years as executive director of the Contra Costa Transportation Authority, recognized as one of the most innovative transportation agencies in the United States. He founded Momentum Station, the largest security automated vehicle test facility in the nation. Prior to that, he was a 27-year employee of the California Department of Transportation, Caltrans, where he rose through the rank to become the Chief Deputy Director from 2004 to 2009 and Director from 2009 to 2010. He's an internationally recognized leader in transportation research and innovation, and is frequently called upon to speak to the latest developments in automated and connected vehicle technology, development and testing. He has been on dozens of TRB committees and research panels over the course of his career, serving as the chair of several of them. He was named as a senior fellow by UC Berkeley Institute of Transportation. Well, we are so glad to have Randy to speak with us. Let's join me in a warm applause to welcome Randy. Thank you.
Thank you.
For those of you who might have questions, you might type them in the chat box and or raise your hand. We might give it to Mr. Iwasaki to address your question. And today's presentation will last for 15 minutes and following by 10 minutes Q&A.
So I have 15 minutes?
50, sorry about that.
50? Oh, okay, all right, 50. All right, now 50. We're talking, because I got a few slides I want to show.
Yeah, appreciate that.
I'm going to share my screen. Does anybody have any questions right off the bat? Nobody? Okay.
Yeah, we can see that.
Let's see here. Let me start the show here. Is it in presentation mode?
Yes.
Okay, well, thank you for inviting me. This is not the first time I've spoke at UC Irvine. It used to be in person. I remember Dr. Ritchie, we used to have this event at 7 o'clock in the morning. And so we'd all have to get up really early in the morning and address, I think it was industry and students. So there's always been a great collaboration since my days that I worked for Caltrans with the universities, including UC Irvine. So thank you very, very much for remembering me and allowing me to come talk a little bit about cloud, mobility and transportation in the cloud. So in 2018, Amazon Web Services, the leaders decided transportation was a good focus area. And so they hired the guy second from the left, Phil Silver. And Phil started the program, and there's 8 subverticals, which I'll highlight that we focus on. But I want to take a little bit of time to kind of focus on our team. And so the guy next to Phil Silver on the far left of your picture is Ravi Talluri. Ravi Talluri is a solutions architect at Amazon Web Services. He's been at Amazon for about 3 or 4 years, and then with us at Amazon Web Services for about a year. The important thing here is he worked for Capgemini, Ford, and General Motors. He worked on Ford's and General Motors connected vehicle data platform. And so he understands how the automobile sector, the mapping, those kinds of things operate. Very knowledgeable in that space. To Phil Silvers, he's third from the left. That's my boss. That's Casey Burns. And he's been with Amazon Web Services for 6 years. And he's a great boss. He ran Health and Human Services vertical for a long time. And he really knows the ins and outs of technology and operating within the AWS kind of structure. And then I'm next to Casey, and then the two people on the far right. So I joke, but it's true. When they hired me in 2021, they doubled the staff. That's how important they thought. They said we're going to double the staff at Amazon Web Services. We went from 1 to 2, and then I got to hire 2 more, and they were in the hiring process. It's a very arduous hiring process at Amazon Web Services. But Tyler, the guy on the right, so basic, is a registered civil engineer in the state of Georgia, but he focuses on airports. He used to work for Amazon Air, and now he's with AWS in the transportation vertical. He's been there about a year. Next to him is Tracy Trexel. She focuses on tolling. And so the reason why is when Phil was writing up the documents and kind of focus areas, he focused on airports and he focused on toll roads. For him, that was easy. When I got hired in 2021, they asked me, what do you want to focus on? And I said, it's very simple. If you think about transportation, I want to focus on DOTs, both state and local. I want to focus on metropolitan planning organizations and council of governments. And I want to focus on transit. And they said, why is that? And I said, because that is where the money is. And so the validation occurred when President Biden signed the transportation bill, the IIJ, or the bipartisan bill. And there's $1.2 trillion in that bill to be allocated over 5 years. And if you look at that bill, $650 billion is to extend the FAST Act, which is, there's an increase in the amount of money that we have into the future to allocate for transportation. I think they've created, or I know they've created a local bridge funded program as part of the formula-based program, which allows then agencies to start focusing on those. In California, when I was a director, we had 25,000 bridges. About 12,700 of those bridges were state. The other remainder were locals. But there was more focus on the state bridges because in many cases, they carry more traffic than local bridges. But those bridges are very important to maintain. And so that was a plus, I think, in the new bill. But I used to go to Washington, D.C., and when I lobby for, you'd always go to D.C. for money, but more so for regulation reform. And I used to say, if you're going to increase the bill, make it like it was in the old days. Make it more competitive grant programs, because competitive grant programs really bring out the innovation out of the transportation sector. And so there's about $550 billion now that are going to be allocated over 5 years competitively. Now, I'm not saying that I got that in the bill, but I'm saying that we used to talk about competition. And I know that Dr. Ritchie has gone after many grants, teamed with other agencies. And you do that by thinking big. You think, what is the art of the possible? And so that's our team, and I'm very proud of that team. We've got an open rec for job opening right now. And it's been open for since January. We've interviewed a few people, but it's a very peculiar and arduous process to go through the hiring process at Amazon. This next slide takes a bit to load. I love whimsical pictures. And so this is the eight sub verticals: airports, seaports, DOTs, toll roads or tollways, transit, parking, departments of motor vehicles, and NPO and COGS. And so these are really agencies that we're focused on, and we're trying to make sure that they are more efficient and they can meet the needs of the customer. And that's really what it's all about. So this is our website. So if you're interested in learning more about transportation at Amazon Web Services, this is the website. I'll leave it up for a moment if you want to copy that. So then this slide right here is, I gave this speech or this slide deck, a portion of this slide deck at the Transportation Research Board's annual meeting, because there's getting more and more interest on the cloud. And so these are, I think, how partners can start benefiting from the cloud. So if you're an agency, most of the software in days of old you used to load onto your servers in your office on your server racks. Now it's all becoming software as a service. I just bought a map update for my car, and I plug something in. And in the future, there's going to be no plug-in. You're going to opt in, yes, you're going to have a satellite hookup, and it will update much like Tesla. you're starting to update that software at night when the car is parked, you've got Wi-Fi, and you're updating that software. You have unlimited storage. Oh, wait a minute, I'm on the wrong side, sorry. This is why the time is to innovate. I'm looking at the wrong screen, I apologize. And so these are the reasons why right now is the right time. I was wondering why these slides were out of order, but they're not. So safety is our top priority. I just gave a speech to Amazon Web Services yesterday. I remember when Norman Mineta, who recently passed away, he's the longest serving Secretary of Transportation over 5 years. In 2001, about 42,900 people were killed on our roadways in the United States. He said our top priority at US DOT is safety. We're going to reduce that number. In 2002, is 43,005 people that died on our roadways. Last year, in 2021, 42,900 and some perished or were killed on our roadways in the United States, which is a 10% increase over 2020, which is around a little over 38,000 people. And 10% of those fatalities are pedestrians, vulnerable road users, bicyclists. And these are things that I think you as moving into transportation are going to have to focus on is how do we leverage technology? How do we leverage automation to get that fatality rate down to zero? Because the way we've done things in the past is not working. You have an aging infrastructure. So the infrastructure is getting old. In my day, we built a lot of the interstate system. I've maintained portion of the interstate system, but as I transition out into retirement, that infrastructure is getting older. So there's opportunities there to find new ways of maintaining and refurbishing that infrastructure. Funding, I mentioned the bipartisan bill, so there's more money now than ever before. And you're hearing more about smart cities. Well, how do you make a city smart if you don't have good data? The Biden-Harris administration have also made equity a focus area. And they want to know, how do we use transportation to raise everybody's economic status? And if you don't have good data, you're guessing. And so we can store that data, safeguard that data, the PII, the personal information, and make sure it's in a secure location, and allow researchers, practitioners to begin to work better at, or finding better information to make better decisions on, will that transit extension really make a difference to the underserved? And then software, I mentioned SaaS. And then I'll talk a little bit, because I talk a little bit about on the next slide. And then artificial intelligence and machine learning. I've got a slide on that because I'm really interested and I'm really excited about the potential there and then the cloud. So I mentioned SaaS. So I mentioned you got unlimited storage. Cybersecurity is important. I have a slide on that. You can control access. And so if you don't want me to access your files, I can't access your files unless you give me the password. And so you can have access control, document management. Which version are you working on? You have artificial intelligence, machine learning. And then I have a slide on Outpost, but Outpost is really a virtual private cloud. Wherever you need it, it's a container. And so you can have a container along a road that's giving you problems, or a transit extension that you need more information from. And lastly, it's a private 5G LTE network. So the NFL has partnered with Amazon Web Services to create a private LTE 5G network in a stadium. The head coach wants to be able to talk to the defensive coordinator in the booth or the offensive coordinator in the booth, and he doesn't want any interference. But you got 65,000 people all on the internet. And so we developed a system that can actually make that whole area on your own network. So airports are really interested in this technology because they have a lot of customers. They want to provide better service. They're trying to find ways of making money, making additional revenue, because they learned SFO, for example, 60% of the dollars on plane landing, 40% on parking and concessions. Well, Ivar Sataro is the CEO. He wants to change that. He wants to raise more money on revenue. So how do you do that? And so he's looking at innovative ways of trying to figure that out. Because if there's ever another pandemic, which there may be, and planes don't land as often, he still needs that revenue to make sure that his books are balanced. So what is the cloud? The term cloud computing refers to the on-demand delivery of IT resources via the internet, pay-as-you-go pricing. That's as basic as it can get. Instead of buying, owning, and maintaining your own data centers and servers, you can acquire technology such as compute, storage, power, databases, and other services on an as-needed basis. It's similar to how you go home and you flip a light switch on. The power company delivers electricity to your house, your lights go on, you start to pay. And when you flip those switches off, hopefully the power company doesn't continue to charge you. You're no longer consuming electricity, so you stop paying. It's very similar to utility. And one of the main reasons that organizations around the world are choosing cloud is it allows them to innovate faster. And so with the cloud, they can focus their highly valuable IT resources on developing applications that transform customer experiences instead of managing infrastructures and data centers. So this is really important. And so you can spin up resources. You've got a website you want to try out, so you have your friends look at it. You spin it up in a test environment. They take a look. They give you feedback. You shut it off. You make the modifications. You turn it back on. Well, every time you shut it off, you quit paying. Every time you turn it on, you start to pay at a lower rate because you're going to have volumes of scale. So you're going to have the ability to spin this up in the areas in areas of the cloud that nobody else can see. And so from a public sector perspective, a lot of times you don't take risk. Why? Because you don't want to fail. In this case, you're going to pre-test whether or not you're going to fail or not. Turn the resources off, go back to the drawing board if it doesn't work. And so here's really how AWS, any cloud provider, this is how it helps. Agility, you can quickly spin up, I mentioned this, you can quickly spin up resources as you need them, deploying hundreds or even thousands of server in minutes. This means that you can very quickly develop and roll out new applications, and development teams can experiment and innovate more quickly and frequently. If it doesn't work, you shut down the servers and stop paying. You go back to the drawing board. The Southern California Association of Governments has gone SCAG, they're your MPO in the Southern California six county region, 10 million households and over 19 million people, largest MPO in the nation. They're on AWS. What used to take 12 to 14 days to run their activity-based model, now it takes them 3 days. If you have a rolling brownout or a blackout or your server glitches, you don't have to start over. We have redundancy and I have a slide on that. I mentioned cost savings. So you only pay for what you use. When you turn the servers on, you pay. When you don't, you don't. Elasticity. So the best way I can explain this is Prime Day. I know all of you don't buy anything from Amazon, but if you did, on the Prime Day, everybody flocks to Amazon because it's a deal day. You're getting the discount. And so they go on to Amazon. So you go from 28 million customers to 48 million customers. And within seconds, somebody answers the phone. How is that? Well, most agencies, when you have on-premise servers, you don't buy the servers for the normal hour. You buy the servers to handle the peak. And so most of the time, much like your car is parked 90% of the day. Most of the time, those servers aren't being used. And all the compute engines you're buying. And if you're modeling, which I know that you do some of that modeling at UC Irvine, you have to update those models. You have to update the compute engines. We do all that for you. And so this is really kind of an explanation of elasticity. And then, as I mentioned before, innovation, you can quickly spin up resources, test whether or not your new technology and new idea is going to work. And if it doesn't, shut those resources off, go back to the drawing board. So this is really an example. This is a toll facility. It's a tolling company, but it's actually only a bridge. But their data center was in a flood zone. And so they approached us. We met with David Sullivan, who's now retired. And the previous executive director is now in Texas running the SH-130 toll road. So we had to start having meetings with him. But their data center, the minute they went to the cloud, they have no more problems. I used to have, when I worked for CCTA, we'd have I call it a mark, a negative mark on our audit saying, hey, you don't have redundancy with your data. How are you going to pay your contractors? Because we're on the first floor of the building of a 10-story building. If it collapses in an earthquake in the Bay Area, how are you going to pay your contractors? How are you going to pay your employees? So we went to the cloud. That mark ended. We didn't have a problem with that on our yearly audits anymore. This is our region, so we're worldwide. So this probably won't pertain to you all if you work for a local agency or a state agency. But if you work for a company, private sector, and you're like Agile Assets. Yesterday, or 2 days ago, I was in Austin, Texas, gave a speech to the Agile Assets team. They do asset management. They're worldwide. And so they talked about the UAE, how they want the data stored in Dubai. And so what we're doing in this we have 26 regions around the world, 84 availability zones. and 310 points of presence. Those points of presence are edge locations. And so I have a slide on edge, but edge computing or computing on the edge you have to bring your compute power closer to the host, which is, let's say, a connected vehicle, because you're going to ingest data into, let's say, an Outpost container. You're going to run an AI on top of that to analyze the data. And then the information that the vehicles need is going to be sent back. And if you need millisecond latency or the ability to send information back within milliseconds, you're going to run these edge points. And so we have these, but we're also going to add 8 more regions around the world. We're going into Australia, Canada, India, Israel, New Zealand, Spain, Switzerland, and the UAE. So you've heard a lot about machine learning. So I just have a couple of slides on machine learning. Machine learning really went from being an aspirational technology to mainstream very, very quickly. And for a long time, the technology was limited to really a few major technology companies and some hardcore academic researchers. So that may be some of you. And however, things began to change when the cloud computing became more mainstream. And so after that, compute power and data became more available. And quite literally, machine learning is now making an impact across every industry, such as finance, retail, fashion, real estate, healthcare, even transportation. It's moving from the periphery, the core part of every business. So you'll hear more and more about this. I know you probably already study AI. Machine learning has the potential to impact your business across multiple fronts, including improving existing projects and creating new ones. So a lot of the companies in transportation that I get to work with are starting to deploy this technology to help make better predictive analytics, for example, for traffic. So Amazon SageMaker, and by the way, this is not a plug to buy Amazon or AWS. I'm just work for Amazon, and I think these technologies are pretty cool. And so I wanted to highlight these. There's probably examples from the other competitors or the other cloud providers. I just don't know what they are. But I thought these were pretty cool for transportation. So Amazon SageMaker is one of those. It's the most complete end-to-end machine learning service, helping you through improved agility, productivity, and some cost effectiveness. And Amazon Web Services built SageMaker from the ground up to allow every developer and data scientist, which some of you are, to build, train, and deploy ML models quickly and at a lower cost. To accomplish, we provide the tools required for every step of the ML development lifecycle and integrated, fully managed service. In fact, we launched over 50 capabilities in the past year alone. And last year, we launched Amazon SageMaker Studio, so you can access all your tools in one location. So this Amazon Studio, it's really an integrated development environment or an IDE. And so what is it? So you've probably heard these technologies described in a number of ways. So let's take a step back and talk about what they are. So AI is a way to describe any system that can replicate tasks that previously required human intelligence. This is almost always related to some kind of complex decision-making where human judgment is required. Most AI cases are looking for a probabilistic outcome, making a prediction, or a decision with a high degree of certainty, similar to human judgment. Almost all AI systems today are created using machine learning. So that's really important. So AI is a product of machine learning. Machine learning uses a large amount of data, thus you need the cloud to create and validate decision logic, which is known as a model. And I'll talk a little bit more about this as an example. An AI application then feeds input data into that model, and the model outputs human-like decisions. So machine learning is the underlying technology powering intelligent systems. Finally, deep learning is a type of machine learning that uses a technique known as deep neural networks. The systems replicate how the human brain functions, which allows more systems to address more complex use cases than ever imagined. I mentioned edge. So Outpost, you have a container that is alongside, let's say, that road that takes you just don't know what's happening. It's a rural road. And what's happening today is your cell phone coverage is becoming, or when you go to 5G, your cell tower spacing is becoming closer. So you have power in places that you never had before. And so Outpost is a container that needs power. And so when you're out there at a cell site, you can actually get in power, get permission, put that outpost container onto a cell tower. It could be even a street light in a city. It gathers information. You run AI tools, machine learning tools to create the artificial intelligence. You're training the thing to look for whatever it is you're looking for, like congestion, wrong way drivers, things like this. And then you provide millisecond latency back to the host or the vehicle. And so I mentioned local zones. We have local zones for provide better access for artificial intelligence. And then Wavelength is another AI tool that will help researchers and practitioners develop better information for the owner operator, in my case, and for transportation agencies. So this is Panorama. So this is an actual use case. So Panorama is an edge device that takes a direct feed off of a CCTV. So as you know, in California, for sure, there's thousands of CCTV and they're dumb. CCTVs are actually just look. And at the TMCs around, I can talk about Caltrans's TMCs, the operators don't know there's an accident because the camera saw it. The operators know that they saw that there's an accident because either the speed maps are going from red to green or from green to red, or the 911 calls. And so they're getting a bunch of 911 calls about an accident. They turn the resources that they have, which is cameras in many cases, take a look at what's happening out there. What happens now is Panorama was developed not for transportation, but for distribution centers. And so what they used to do is they look at the cameras, they're face down and how the operation is working. Manufacturing does this as well. And they look at how the boxes are arranged, how efficient is it? And they're teaching using modeling behind the Panorama tool on what to look for as far as efficiency. In the case of CCTVA, you can actually teach it to look at tail fin numbers on aircraft. It could look at luggage as it's being offloaded and then unloaded into the carts and then transported into the luggage bays to be put to the right wheelhouse or the turnstile, so you can get your luggage as you offload the airplane and go to the baggage claim. But in our case in transportation, what I thought was pretty cool is the edge box, in the case of airports, is looking for dwelling vehicles at the arrival zone. And so currently what happens is you have to go out, if you're the person that has to monitor that, you're looking, you're keeping your watch, you're trying to figure out if that car says dwell there longer than 3 minutes or park there longer than 3 minutes. What's happening today in Cincinnati Airport is looking at cameras, they're running AI behind it, and it pings a smartwatch saying, Randy, in location Z, the end car has been there longer than 3 minutes. So I just walk outside, tap on the window, say, sorry, sir, or ma'am, you've been there longer than 3 minutes, you need to move your car. And so it's all becoming AI. So it's transforming the way we're taking a look and using cameras. So it updates all the cameras that are in inventory. So another good example is wrong way drivers. So on the Bay Bridge in San Francisco, there's a lot of wrong way drivers. Typically, it doesn't end well. And so how do you alert the officials when you see somebody making the wrong move onto the freeway? Well, you can take a look at flow this way and say, this is not good. You can run models behind that image on Panorama, and you can start teaching that camera to be smart. The sky's the limit as far as modeling. The more complex, the longer it's going to take to teach Panorama, teach the camera to look for things. This really is what it does. And so I mentioned before tracked objects, and this is really the use case that we're trying to figure out how to apply for transportation to make, once again, transportation safer. You're going to drive that fatality rate to zero. You're going to have to overcome driver error, equipment malfunctions, illegal maneuvers, all these variables. You have to work on that to make us a safer place for our pedestrians and our vehicles and our bicyclists. Interesting point. And so the amount of data we're gathering using video and the amount of data we're storing is increasing every 2.5 years. And yet, 98% of that video is not recorded. Now, when I first started with Amazon Web Services, I had to take a lot of training courses. And at my age, I didn't want to take any more training courses. I had to become cloud practitioner certified. So I had to study day and night, like I was studying for the PE exam again. And I almost quit. I said, if I don't pass this test, I quit. Well, lucky I passed. But I took a test, a test the other day, a class on data. And if you're a Fortune 100 company and you can analyze just 10% more of your data, your revenue is going to increase by $65 million. Now, I don't know what a Fortune 100 company makes and how much $65 million is relationship to, let's say, $2 billion of revenue a year. But $65 million in my book is a lot of money. And so that kind of gives you an idea of the power of data analytics. If you can store the data, you can start analyzing the data, and you can, in some cases, make more revenue, provide better services to your customer. The California DMV has gone all on AWS in their contact centers. They're gathering information, so all the complaints that came in are now being analyzed. If it's a yes or no answer, a bot actually answers yes or no, but it highlights or classifies all the complaints and it sends it to the right agency. So the time you're waiting on the phone at DMV is getting less and less. The last thing I would show you as an example is twinning. So if you're not twinning, you're probably twinning at UC Irvine as students already, but manufacturing has used twinning for over a decade now. And so GE, when they're building a jet engine, like you see on the right, they're going to twin a model and they're going to mess up that model. Well, in infrastructure in the city of LA, there's a company trying to digitize the infrastructure, build a model, and then getting ready for the Olympics, they're going to tear apart that model. They're going to see how they can make the city of LA operate better. So this requires a lot of data storage, a lot of data analytics. And so it's not futuristic, it's here now. It's been here. Transportation recently has started using twinning. And so I think that's a futuristic or a future technology that will help enable you to make better decisions on both sides, either if you're a public sector person as well as a private sector person. So lastly, this is the last slide. So we have a shared security model. I'm always asked about security, cybersecurity. Is the cloud really that secure? Well, Amazon Web Services takes care of the facilities and the cloud, the shell. The owner takes care of the data. You encrypt it at rest or in transit. You implement a multi-factor authentication. You have access control. You patch your software and we patch our software. And so together, you can't have somebody plugging in a rogue server into your server rack with no protection. And then that's an endpoint that's unsecure. And so that's really the way I like to explain cybersecurity, but we have a lot more on that. And it's a lot more information than I can explain to you. But if you have any questions about cybersecurity, we have a whole vertical alongside transportation that focuses in on cybersecurity. Thank you for your kind attention. So that was about 30 minutes. So we have time for questions. Let me stop sharing my screen here.
We have plenty of time for questions. I saw a question from Craig, Dr. Craig. Craig, would you like to unmute yourself and ask your question?
Hey, Randy, how's it going? Nice to see you.
Good.
So my question, you at one point mentioned, the power of elasticity and running, for instance, activity-based models on AWS. And I was just wondering, there are a lot of transportation models that are commercial off-the-shelf software. How easy is it to scale that sort of commercial off-the-shelf software on AWS? Does it require sort of the vendors of that software to have explicit partnerships with AWS and to have designed their software for that scalability? Or is it something that you can just kind of roll out pretty easily? And I ask because, we obviously do a lot of modeling. We use a lot of different software, some custom built, and some just application of things like Cube or Transmodeler and things like that. And, we occasionally have the debate of, well, should we, buy our own systems to run these models, or should we look into the cloud? And I guess my impression is that moving into the cloud requires, I guess, a certain amount of certainty about what you need and what you're going to do. And in research, a lot of what we do is exploratory. So there's a lot of sort of iteration. And at some point, those compute cycles, because you're being charged for every one, makes that cost proposition difficult to sort of estimate. So I'm just wondering how much AWS, if has partnered with, I guess, specifically transportation software vendors to make that process easier.
You've asked a couple of questions in there. So let's go first to your last question about cost. So we'll come in and we'll bring a team in to do what we call a TCO, or total cost of ownership. So we'll measure your compute engines, your servers, the type of compute engine, Graviton X, Y, Z, whatever that is. And then we'll run a cost comparison with ours running at the same speed, with the same power. And typically it's cheaper. And so your other question is about software. And so I was just on a call on Monday. So my weeks are, Amazon will take as much as you will give them. So we're across the nation. So at 6 o'clock in the morning, we're having 9 o'clock meetings on the East Coast, which is totally unfair because at 5 o'clock, they're all at dinner or sleeping and we're still working. But so Bentley's product does not run on AWS currently. But if you say, hey, Randy, you guys, we only can use Cube. Cube is a Bentley product, is that right? Yeah, so that's the one. So Houston, Galveston Area Council saw I met with them on Monday and we met with them earlier, and now their modelers are interested because SCAG has gone all onto AWS. And so the Southern California Association of Government runs their activity-based model. And I mentioned that before. It used to run 12 to 14 days. Now it runs in 3, and it runs. The servers are gone. Their compute engines. We take care of all of that. And so they're going into phase 2 to create a regional data platform. So now the local agencies, instead of sending a paper spreadsheet in, or having to send student assistants into the local agencies then to arrange the data in the right format, because at the end of the day, it's the city's data. You don't want to mess with the city's data because it's their transportation element of their regional plan updates potentially, or their general plans. Then they're starting to create the next generation. So some do, some don't. And so we'll send a team in to take a look at is Vism or Visum or Cube or whatever. Is it compatible, and are there other options? And so you also, if you have a long-term license, we send in licensing experts to say, you know what, it's better for you just to continue to the end of the licensing and run that software until the end, and then come see us in the future. Really what I love about Amazon Web Services is we're not a solution in search of a problem or a hammer in search of a nail. We'll go in and say, what are your top of mind issues? In SCAG's area, they wanted to run that model faster. And then for 2 weeks, they're going to run it. And like they were having outages problems. And, we have outages or disruptions every now and again. But when a local agency will call you and say, hey, you had an outage last Friday. Well, that was the third in 10 years. Yes. But you don't count the outages when the rolling brownouts or blackouts cause your servers to shut down. And you have to run your model again. That's not a disruption to you. And so you've got all those different kind of scenarios. And I know the universities, we have a whole higher ed area. But in the area of transportation, some work on AWS, some don't. But in the case of SCAG, it runs all on AWS. Because
I'm ignorant of that. What platform are they using for their?
I will find out, and I will get that back to you, because I was asked by Houston, Galveston Area Council, and I couldn't answer that. But I'll ask Shiwa. Shiwa is the master modeler for SCAG.
Excellent. No, thanks a lot for the answer. That's really helpful.
Thank you.
Randy, can I ask a question?
Yeah,
yep.
Go ahead,
Somebody
Gabe.
else. Oh, hi, Randy. I just really nice that you mentioned about SCAG and then their AWS is help them on the activity-based model run and maybe land use model run as well. But just curious your thoughts on the potential trend, because I totally understand it's definitely a great improvement from 2 weeks to 3 days. But what do you think is the possibility, like in the maybe near future, you can reduce to like in a matter of minutes or even seconds? Like, given the SCAG's or general MPO's budget, do you think there's a trend there, or 3 days is kind of pretty much the bottleneck now, and it's going to be like this in a pretty near future?
Great question. So the Houston Galveston Area Council asked the same question, and it was the opposite. Hey, that might cost too much money. Can we run it in 6 days instead of 3? And so I mentioned this early on. So the cloud computing is the ability to spin up hundreds or thousands of servers in seconds or minutes, warm those things up, and you can run the model as fast as you want to run it. So you have to ask yourself, there's going to be a time versus cost. What is that balance? Well, for SCAG, 2 weeks was too long with technology the way it was progressing. And so as models get more complex, because as you model, it's not like it was in the old days. You got technology ramping up like this. And so you're trying to look out 30 years. And so your models are getting more complex, and they're not getting less complex. And so as you add more variables into your model, the technology is getting smarter, and the compute engines are getting better, and they're getting cheaper to run. So yes, the answer is you can actually run it very quickly, but it just depends on how much you want to pay.
So the 3 days now is a good trade-off for SCAG, at least. In terms of
Well, I mean, come on, that's a quarter of the time that it used to take them.
Right.
That was unheard of. I mean, they thought they were running fast in 2 weeks.
Yeah, it's pretty. Yeah, they have a very low reference point, I guess.
As a researcher, your projects that you may be modeling may not be that complex, and you want to spin it up in a matter of minutes. You want to see it's going to work, it's not going to work, because you got a thesis that you're due, and you want to run this thing for the last time. You want to make sure that Dr. Ritchie doesn't flunk you in your PhD quest. And so boom, the PhD committee, your last second, you spin it up, you got the results, you walk in, say, these are the latest results.
Mm.
That's the power of cloud computing. You can do that on-prem, but you're going to buy more servers.
All right.
And your rooms are getting smaller, apparently, because when I was young at Caltrans, what I loved about District 6 is the 6th floor of the building was a lunchroom. You could walk in the lunchroom, get lunch, you could eat lunch, you could talk to you could see even some of the big shots, the district director or the deputy, and I was just an assistant. I go, hey, there's the district director, and he say, don't look at him. Don't ever look at the guy in the eye, and if he's coming down the hall, avoid him. But that whole 6th floor now is all server racks. There's no more lunchroom.
Well, all right, thanks.
Any questions from the audience? Professor Ritchie, Professor Jay, Vicky.
Well, thank you.
Thank you. Questions. I just had a comment. I thoroughly enjoyed the talk. Short and sweet. Thank you, Randy.
Randy, I'm a salesman. I'm a businessman guy. I'm not a tech guy, but I can tell you from my years of experience, these things that I show you, it's amazing advancements in the art of the possible of what we can do with this technology. But if I don't tell you what the art of the possible is, these from my perspective, you don't know, and you don't know what to ask. And so hopefully the students in the group, as you grow, as you get into your careers, you're going to say, oh, there's that old guy that made a presentation about cloud computing. Let me take a look at what's happening over there.
Randy, I've got a.
And you mentioned a great, a job opportunity that's going around too. So maybe the students can think about that.
Yeah, it's hard. So well, I would tell you, if you want to come work for Amazon Web Services, what you need to do is don't think about your resume in the engineering perspective. I led a team, I did this, or we did that. I'm a big thinker. Amazon Web Services wants to know what you've done in the area with either the public sector or the private sector, how you innovated, what you've learned. One of the reasons why we innovated so well at Contra Costa Transportation Authority is the board said it's okay to fail. And you'll learn more from failure in your career than you will from success. As long as you take the time to admit it, you made a mistake, and then take the time to learn from that mistake, and then agree that it'll never happen again. And you'll tell people that, hey, I made that mistake. I made a lot of mistakes in my career. I can tell you a lot of different mistakes, but I learned from those mistakes. And you can't innovate typically unless you take risk.
Randy, I want to ask you, this is maybe a little bit fringe, but several things. There was an announcement, I think just a day or two ago, about AWS teaming with another company and the ports of LA and Long Beach, I think. And the idea was to use those resources to sort of digitize and make available the tracking information.
Scheduling.
Yeah, tracking everything through the ports, maybe from Asia through the ports to distribution centers and so on. I mean, obviously package delivery, Amazon and UPS, FedEx are really on top of that. But for freight moving through the ports, apparently much less so, and there's been efforts in the past. I mean, are you familiar with that particular application? How broad it is, or is it just with one shipping line? Because we've been talking to colleagues in the air cargo area, and apparently this is it was unknown to me at the time, but apparently in air cargo, there's practically no tracking at all. It's dismal in many cases. There's instances where specific airlines, specific markets are doing that very well, but in general, apparently not so. But I was intrigued to see that in the ports in our own backyard.
So we just announced that partnership. It was actually conceived before I got here. I got to AWS January 4th of last year. And so that was a think big kind of initiative. So Amazon Web Services, they love these. We put together proposals and send them in, and hopefully if they get approved, they get funded. And that was one of them, is to kind of work with the Port of Long Beach to come up with a better scheduling tool, because these ships come in on the first day that they're able to dock, and then they leave the last day, or they don't tell anybody. And so there's no coordination. And so they got together and they built this system. And so I think it was the Dr. Marcel, or whatever the guy's name is, one of the deputies of the port, has worked with AWS. I don't know all the particulars, but I can tell you the guy on the right of that picture that works with me, Tyler Subasic, he worked for 4 years for Amazon Air. He was an airport consultant. So Dr. Ritchie, if you want more information, I will set up a meeting with Tyler Subasic to go over how we track packages on Amazon Air.
Yeah, that'd be great, Randy. The part of the relevance of this is that UC ITS, the 4 branches of ITS, recently received $10 million from the state for this program called the Resilient Innovative Mobility Program, RIMI. And there are several thrusts within that. One is emerging technologies and innovations, and within that is the freight and supply chain area. And so we're bringing together folks across the UC system to initially, well, actually, truthfully, and I think you know from Susan Shaheen's recent email to you, we're trying to organize listening sessions and educate broadly as we can, and then produce a white paper for the state on how to proceed and address gaps and so forth. And so this is particularly relevant, I think, and that'd be great to have a meeting with your colleague that you mentioned.
Yeah, and I'll try to get you some information on the Think Big. We've got a write-up on that. So there'll be a detailed, what we love is what we call proof of concepts. So we run these proof of concepts, much like SCAG. So I wrote a paper. This is, by the way, this is the first time since 1996 I don't have an executive assistant. So when I became the district director in District 9 in 96, I had an executive assistant. Finally got figured out how to delegate all that stuff to the executive assistant. And now in 2021, I don't have one. So I write all this myself, but we did a blog.
Yourself.
Yeah, we did a blog on the SCAG. I can send that to you if you're interested in that as well, but I'll get you the write-up.
Absolutely.
I'll send it for distribution for SCAG. I'll find it on our Think Big with the port, and then I'll get a meeting with the Tyler on Air. And I'm still trying to find you a package delivery expert. There's 1.6 million people here at Amazon, and I mean, it is hard to find somebody that does whatever it is that you're looking for, because your request is not the first. And I've been searching, and it took me a year to find the people in this kind of area that focuses on how do you contract for building the distribution centers or the data centers. And I finally, after a year, found the right person. Now I didn't work on it every single day, but I called somebody, hey, what about this? And they say somebody else, and then call somebody else. They say, well, this person and that person. Pretty soon you just get tired of it. But I'm still looking for a package delivery expert for you.
All right. Thanks, Randy.
Thanks, Randy, for the presentation. I have a quick question with regard to the safety issue that you mentioned. I was intrigued. I was shocked by how many people was killed every year by the car accident. I'm wondering what might be some possible ways of funding investment in terms of improving the safety. Do we invest in the education or infrastructure?
Yeah, so the 3 E's, right? You have education, enforcement, and engineering. That used to be the kind of the way we, at least because I was in traffic operations for a few years at Caltrans, and I was the deputy for maintenance and operation, traffic operations. So I oversaw traffic operations and maintenance. I know those numbers well. And my theory has been this: if 2 747s fell out of the sky They ground the entire 747 fleet and they figure out what the problem is, because they do not want 400 people perishing twice. And if you look at the 737 MAX 8, they just recently started flying after 2 years as they searched for the problem, because two of this identical planes went down. We don't do that in surface transportation. It's almost like it's accepted. And so we have a great project in Bellevue, Washington. We're partners. It's a proof of concept. Bellevue, this is where data analytics come into play. And by the way, really quickly, the other thing is we got a US DOT grant, an automated driving system grant at CCTA when I was there. Staff of 20 competed against Caltrans, Alabama DOT, UC Berkeley, UC Irvine for those grants, those competitive grants. And we were one of the 8 grantees in the nation. And it was to do 3 pilot projects. And 1, are senior citizens willing to get into self-driving vehicle? 2, using self-driving vehicle technology to lower the absentee rate at a county hospital. It's an issue that because they don't want to go, because when they get out, the bus isn't there anymore and they got to wait in the hot sun or the rain. And so they go when it's a real problem, which is not right. And the 3rd was how to prepare a quarter for the future for self-driving vehicles. How do you ingest the data? How do you analyze the data? What sensors do you need? But we also agreed for 2 proactive safety metrics: skidding and close calls or near misses. And so CCTA wanted to figure out, how do we stop this carnage? How do we use technology to start making predictive analytics? So fast forward to Bellevue, Washington, where I'm going to write a blog on that. It's being written now in my spare time. But we're using LiDAR. So they've highlighted their high injury network, which represents 8% of their network. So they're looking at those routes that they got a high accident concentration. They've looked at the causalities of those accidents. So you got 65% of those accidents are caused by those five speeding, distracted driving, those kinds of things. There's 5. The other 35% are things like mechanical issues, illegal maneuvers, that kind of thing. But 5%. And then they've said 40 miles an hour, you have a 10% survival or 20% survival rate. But at 20 miles an hour, you got 80% survival, or you got 80% survival rate. So now you see Vision Zero plans lowering speeds. You see Vision Zero cities taking what they call a leading pedestrian interval. So get the pedestrian out first. Instead of letting the green light and the pedestrian light go off at the same time, you walk out in front and the car hits you when they're turning right. That's not a good move. So send the pedestrian out first. So it's lower the injury rate in the city of Bellevue. Well, how do they know that? They're collecting data, they're analyzing that data. And so over that 8% of the high injury network, they've actually gone and starting to use LiDAR. And so LiDAR now is helping heat map these intersections and showing the causalities in more refined detail about what's the accident problem. And then they're applying AI to those cameras, saying, is there a prediction that we can make after we get all this information together and we can do something in advance? That's how and then automation ultimately is going to help drive that fatality rate to 0. But they're applying a kind of the same format that the Scandinavian countries have. Norway comes to mind. Norway's gone down to like 1 fatality in the last 5 years. Well, you got to have better transit operations. Your transit operations have to go where the people who walk are. Typically, that's the underserved neighborhoods, the poor, the elderly like me, the old guys, the old people, and the people that can't afford a car. Well, they got to walk if they want to go out. And when they're walking, they're more vulnerable because the highest increase percentage-wise in the fatality rate is pedestrians. So how do you couple all this information together? You have to store it. You can store it on your servers. You store it, or you can store it in the cloud. You start running data analytics. You run machine learning. Teach those cameras to look for things. And so now modifications are being made. I talked to Amazon Web Services team, about 400 people yesterday. You should be concerned about this Vision Zero plans because your kids walk to school. Many of your children walk to school. They're vulnerable road users. That's why you need better, when you talk to local agencies, talk to them about some of these Vision Zero plans and why they're important. And you got to get elected official buy-in as well.
Well, thank you, Randy. And any last minute questions from the audience?
I'll tell you another cool, real quickly, since I got a minute. We're actually using LiDAR to detect a 1 by 1 inch cube on a runway. Right now, they drive twice a day looking at that runway. They're pulling up cell phones, washers, bolts, nuts. Well, as they redefine the aerodynamics of jets, the jet engines are getting closer to the ground, and they're sucking these things into the fins, into the jet engines. So if you have a cell phone out on the runway, I don't know how a cell phone gets out there, but there's documented cases. Well, this thing's getting sucked right into those jet engines. And so we're using technology to try to make surface transportation, air transportation safer.
Wonderful.
Thank you. Yeah, Dr. J.
Thank you again for this. It's always great to talk to students. Good luck to all of you. And then thank you to the professors and the teachers for all the hard work that you do. Sometimes it's underappreciated, but not by me. I'll tell you, you guys do a great job of educating, well, me for sure, but the students as well. So thank you for that.
Thank you,
Yeah.
Randy. Thank you for your time. And let's join me in the applause. But thank you for Mr. Iwasaki. Thank you. Thank you for your
My
time.
pleasure. Vicky, good to see you.
And,
so much.
yeah, and have a great weekend.
You too.
Thank
Bye.
you. Nice to see you, Randy, too.
You bet. Bye.